Good afternoon, and thank you for attending the Leak Detection and Predictive Preventive Maintenance Solution webinar being presented to you by Teledyne FLIR. My name is Keith Cornish, and I'm the Senior Account Manager here at Photronic. We do business as Test Equipment Depot. We're a nationwide distributor of Teledyne FLIR products and happy to be hosting this presentation today. Today's presenter is Russell Hall. Russell is Channel Partner Manager for Teledyne FLIR and is a certified level 1 thermographer. He's been with Teledyne FLIR for 2.5 years. Before we begin, I want you to know that there will be a question and answer period after the presentation. So please feel free to stay online at the conclusion for that. Again, thank you for attending, and now I'll turn this over to Russell.
Great. Thanks, Keith, and Photronic for hosting this webinar, giving us an opportunity to talk about two relatively new solutions from Teledyne FLIR. So very excited to be here with you guys today. I just wanted to put a face to the name, but I am going to close off my webcam here in just a minute as we go through the presentation to make sure that I have enough bandwidth to get through the PowerPoint and some embedded videos and all of that. But definitely, like Keith said, if you have any questions, type them in the chat. We'll get to those after the presentation. I anticipate this to be about 40-45 minutes as we go through some of these different solutions and why they might come in handy for your facility. All right, so let's get started. All right, so obviously, today's webinar is about leak detection overview. So we'll go over how, maybe in the past you've found some leaks, or maybe you're not doing that today, and some solutions that we have available. So just kind of the overview, why it's important. And then we'll dig a little deep into two of our solutions that are both, very versatile cameras. One is our gas detection, our GF77 camera. The other is an acoustic imaging camera, which is a new category for Teledyne FLIR, is our SI-124, so our sonic imager. And then again, we'll have some Q&A at the end. All right, so first, target users and applications, right? So there are so many different utilities out there that have gas running through them or are using, high energy, high voltage equipment, right? Over 3,300 utilities across the U.S. Co-ops, municipalities, electric generation, nuclear, natural gas, coal, renewable energy, all of these users, all of these facilities, can definitely benefit from these. So if you are one of these people joining today, kudos to you. I think you're going to enjoy this. And then just, again, like, do you have gas or air leaks that are hard to find in your facility, in your plant? Do you think they're there, but you're not sure because you can't see it? It's like, I probably have it, but I don't know how to detect it. Do these potential leaks create a safety or environmental hazard at your facility? Do these leaks cost you money if left unattended? Right, we pay to heat our house, right? We pay to run our facilities, to power up our computers. If we have all of that going through and, electricity or gas running through a facility and it's being leaked or wasted, right? That's just lost money coming out. That could easily be salvaged. Do you want to find partial discharge failures? Do you want to improve the reliability of your operation? Do you wish every employee had access to a thermal camera for quick checks and safe working environments? We will do just a quick plug for, some of our legacy products, and what FLIR is known for, worldwide leader in thermal imaging technology. Do you think thermal imaging cameras are expensive? So if you've had any of these questions, or you've answered yes or no to any of these questions, again, I think you've found yourself in the right webinar. Look forward to being with you here throughout the next 40 minutes or so. So how do you actually find a gas leak? right? Because gas, as we know, is invisible to the naked eye. So since the early 80s, the gold standard for leak detection has been Method 21, or also known as TVA, Toxic Vapor Analyzer, which is a slow and labor-intensive process, taking several days to complete a thorough survey. In addition, the TVA must be in contact with the leaking component in order to detect the gas. So if the operator misses a leak, or the leak point, it may go unnoticed. It also requires the operator to be in harm's way during the inspection. If you have active leaks going on, and you got to get really close to them, right, that is a potential issue. Another method has been, the SNOOP, or soap and water testing, right? So you take some soap, you take some water, you put it on the valves, and you look to see if that water turns bubbly, if that soap turns bubbly. If it does, that means you have air coming out of there, you have gas coming out of there, and there you can pinpoint your leak. But again, this is going to be a very labor-intensive, very hands-on, putting yourself in those dangerous conditions. A little more recent way of doing this is with an RMLD, laser assisted. So this, you can scan larger areas, but you may be limited in the gases that it can actually detect. So this solution will actually kind of step you away from the environment a little bit, which is a good thing, but it's still going to be more limited on the different gases that it can detect. So some other common challenges, right? And we kind of already touched base on a couple of them. One, it's time consuming. You have a big facility, maybe hundreds of thousands of square feet. It's time consuming to do these scans. It's hard to pinpoint where the leak is coming from. Again, you might have, thousands upon thousands of potential leak points, and you got to go through all of those to try and find it. Again, if you're walking around with a bucket of water and some soap, right, you can imagine walking your facility and the labor that might entail. Then again, it becomes more dangerous when you're around this energized equipment, or these, leaking environments with harmful gases. We see this picture right here, right? Probably a lot of you folks out in your facilities have this at your facility. Danger, no smoking, or lighting up, no matches, all of that, because that your place of employment, your work, they know that there are potential leaks, or more common, you probably do have leaks in your facility. So if somebody were to light a cigarette, it could be a bad day for them and others. It's easy to miss these leaks, and they can happen, right under your nose. So even if you know there's a leak, or you're very susceptible that there is, very suspicious that there is a leak, you still might not be able to catch it. Again, our senses, especially seeing, gas, we cannot do that. If you hire somebody else to do it, it could be very expensive, right? You can go and you can get audits, you can hire third parties to come in. That could be very time consuming and expensive, as well as the actual gas that you're wasting is expensive. So if you don't do these, it's just gas coming out of your building day in and day out. Again, I live in Wisconsin, so we have very, very cold winters, and then we have hot summers as well. So for 6 months, 8 months out of the year, we either have the heat on or the air conditioning on. And when it's cold outside, in 10 degrees, Fahrenheit, we have the heat on, and I turn the heat on to, 70 degrees, 69 degrees. I do that, but I'm not also going to open up my front door, right? I don't want to heat up the outside or let that cold air come through, right? I'm going to lock all my windows. I'm going to, close my door. Right. I'm paying for that. I'm paying for that furnace to work, to heat up the house. I don't want it leaking out and make that furnace have to work harder, and then also pay more money to my utility company for the gas that I'm blowing out the windows. There's also environmental considerations in utility. If you have SF6, or, you know, power generation, methane gas coming out, right? Those are obviously harmful gases to the environment. So not only expensive, but also, you know, we all want to do the right thing in protecting the environment. Lastly, safety, right? Safety is it's on the bottom of the list here, but really the number one concern. If you have these potential gas leaks go unnoticed, they can cause explosions, like we talk about the different dangers in those facilities. So then another obviously open-ended question for you all is, you know, you sit on this webinar, but, you know, do you or your employees wear PPE or flame-resistant clothing? And probably the answer is yes, right? If we were all unmuted, I'd hope to get a resounding yes, that we're all wearing PPE. But really, PPE, it's great. I wear it, I love it, but they're like seatbelts. It's the last line of defense, right? Before we get in our car, you know, or when we're driving around, we make sure that we're driving on the right side of the road. We make sure that if there's a red light, we stop. You know, when it's green, we go. If there's a stop sign, we stop and we wait for traffic to pass. If it's dark out, you know, we turn our headlights on. So the seatbelt does not protect you from everything else that you have to do, right? You can't just put on PPE and be like, okay, I can poke and prod and touch anything, open up cabinets and not be worried about it because I have PPE on. No, that's not how it works. You can't, you know, you can't get into a car drunk and expect to make it home safely. So the seatbelts, they don't prevent the car crash. And just like PPE, it doesn't prevent the arc flash, you know, in certain instances. Again, you know, do you drive at night without headlights, right? Again, hopefully the resounding answer is no. So why do we do electrical work in the dark, right? Or why do we do utility work in the dark? We put the PPE on, and that's great. Again, big advocate of PPE, but there's many steps and many things that we can do before putting the PPE on that can also keep us safe. So there has to be a better way, right? What if I could scan, what if you could scan large areas quickly and safely at a distance like the RMLD has? And what if you could pinpoint exactly where a leak was coming from, like a snoop or a TVA sniffer? What if you could document all of this in a picture or a video to show the exact location of the leak to make repairing faster, right? And that's what two of the solutions we're going to talk about today are. And the first one is our GF77. So we can check all of these boxes. We can do it from a distance. We can give you the exact location, and then you can actually document, build a report, and share that information with others to go about and have them make those corrections and fixes to keep your facility up and running, to save you money, and to keep you safe. So the GF77, GF standing for gas finding. This is our first optical gas imaging camera that's also versatile enough to see thermal. So this is actually a 2 cameras in one, really a 3 cameras in one. It can see thermal and it can see gas, and it can see gases in different different wavelengths. So again, the map here above is all of the natural gas and electric generation plants in the United States. Again, you know, we have thousands of these. This one camera solves basically all of their problems that they might run into. One, it can detect methane gas, right? 2, circuit breakers near the generation plant. If you're having that SF6 leak, it can detect that SF6 gas as well. Even plants that have combined cycle that use ammonia, this camera can pick up ammonia leaks and detect where those are coming from. On top of those 3 main gases and some additional gases as well, it can also be used as a thermal imaging camera detecting hot spots. So you can do your predictive and preventative maintenance, you know, with thermal imaging as well. So it's really, you know, a jack of all trades type camera that packs, just a ton of value. So let's talk a little bit about how does optical gas imaging work, right? So we have a little valve here that starts leaking. And sometimes if it's thick enough or, like a smokestack, right, we can see some of those gases or some of those smokes coming out, and it kind of looks, something like this might work. But the ones that we can't see, right, the gas leaks that we can't see with our human eye, how does that work? So every object emits energy, and it emits them in different wavelengths. So when we have this object, a valve, a skid, whatever, it's emitting energy, and if it has a leak, it's going to send that energy in towards the camera, right? You're pointing the camera at it, and the camera will detect that. Now, if you have a leak, if there's a leak in front of that object, right? Now, when that object is sending these wavelengths, back to the camera, some of them are going to be blocked. And in our camera, it's going to look like smoke. So only some of this picture is going to get through to the camera. The rest of it is going to be prohibited by the gas that is leaking. I've mentioned, wavelengths a couple times now. So the electromagnetic spectrum. So humans, right, we see in this visible light. If you go to the doctor, you might have X-rays, right, gamma rays. So where our infrared cameras mainly play are in this micron range from 0.4 to 14 microns. And then inside of here, we have mid-wave lengths and then long-wave lengths. So thermal imaging is usually between like 8 and 14. A lot of that is long-wave. I promise there's not a test after this, and we're not going to dig too much more into the theories of how these cameras work, but just to let you know a little bit of the basics here. So what we do is we actually match the spectral response of the camera to the peak spectral absorption of the gas. So like I said, only some of these wavelengths are going to come back to the camera because that gas is going to impede it. So where the absorption is, where the gas absorbs all of that reflected light, that's where we're going to match our cameras or our lenses to that gas. So if we look here at some of the different gases that our GF77 camera picks up, the two big ones are between like 7.5 and 8 microns, and then again like 8.5 to 12 microns over here, 9 to 12 microns over here. So basically, what this is saying is where the gas is a poor emitter, we tune our lenses to that to see it. And if none of that made sense, hopefully this video will, and hopefully this video is coming through good. So right here we have a fuel gas skid that has methane running through it. So the question is, well, so first, hopefully you can see this, right? It looks like smoke being leaked out here as this plays. We also have something called high sensitivity mode. So you can switch the different modes of the camera as well to go back and forth. These cameras can also take visual images and visual recordings, so you can actually, identify with your eyes, if it's labeled or, marked exactly which skid it is. So one question that, some folks commonly have is, don't we already solve for methane leaks with mercaptan? And the short answer is yes, but in most plants that have natural gas, you can start to smell, right away when you walk onto the grounds. So the mercaptan is, a smelly agent that we put into our gas so that we can smell if it leaks, right? Because methane gas left untreated, it has no odor. So what we do is what utilities do is they put the smelly substance in it, mercaptan, so that if there is a leak, we can smell it and it smells bad. Some people think it smells good, but it's to alert us that there is a leak. But what we find is in a lot of these plants, that smell is just there all the time, because maybe they have little leaks all the time. So it's hard to pinpoint. If you only had that smell once in a blue moon, then you might be better able to pinpoint it. So when you go into your work environment, it might have a certain smell. When you come back to your house, if your oven was leaking methane, right, that would be a new smell for your house, and your senses would be heightened. You'd say, my house, my kitchen never really smells like this. I think it's leaking gas. That's a big shock to your system. But when you go onto a gas power plant, or a different facility running methane gas, you're not going to have that shock factor. So it's still important to find these leaks. Here's another image, or another video, I should say, of a flange that is leaking methane as well. Again, video captured by our GF77 camera. This one actually runs through all the different modes that our camera has. Again, so you can see the normal mode, the high sensitivity mode, and then a nice visual recording as well. So you can use context clues to know exactly what flange this is, so that you can send people there to make the make the appropriate change or repair. And again, remember that image that said no smoking, right? This is why. You might walk by this day in, day out, not knowing that it's leaking. And if you light up right next to this thing, again, it's going to be very dangerous for you and everyone in that facility. Switching gears a little bit, this is an image, or this is a video of an SF6 leak on a circuit breaker. So same camera. You can see here, and I didn't mention this before in the last videos, but this is our high range lens, our high range optic. So the other ones had a little red square indicating our low range lens. This one we're using our high range lens. So the lenses can see different gases, and like we talked about, the lenses are tuned to only see certain gases. So SF6 is, sulfur hexafluoride. So in order to detect this, again, all we have to do is change the lens. You can use the same camera for the two different lenses. But SF6 is very common to be used in, power generation. You kind of see the smoke coming out here. This one is a little harder, especially on the webinar, but the leak is coming right out here. Again, SF6, very dangerous to the environment, very expensive. We have these leaks. We want to shut these down to save money and to make sure that we're staying safe. And then lastly, here's just an image of a basic image of a connection at a substation. Nothing wrong with this. The heat pattern is normal, but just a nice clear picture here of the detail that you can get with this camera. Again, now this one you can do thermal imaging with either your high range or your low range lenses. So here we're back to that low range indicated by the red square. Just taking a nice thermal imaging camera. So if there was a problem here, we'd be able to find that, we'd be able to see that, and then again, we'd be able to implement the correct repairs to get that fixed. So just some quick features and benefits. Again, we have data sheets. You could check that out on photronic.com. They have, they sell this camera. They got all the information there. You can also see it on FLIR.com. But again, when it comes to the thermal, you got 3 different temperature ranges that range from -20 degrees Celsius all the way to 500 degrees Celsius. We also have something called routing. It's part of our software package that is enabled on the camera. If you have many different assets that you need to inspect, you can actually you can pre-populate a route in your camera. So it'll say, okay, first we got to go to asset 1, you know, and then we got to go asset 2, asset 3. And for each asset, you have to take an image or take a video. You can take notes on it. So it just helps make sure that you go out and complete everything that you set out to do without wasting time or energy, missing things or having to double back. The accuracy on the thermal imaging camera is plus or minus 3 degrees Celsius, which is pretty good, again, for predictive preventative maintenance. You know, you're really just looking for heat anomalies. Then our HR lens, our high range lens, again, the spectral range of 9.5 to 12. The primary gas here is going to be SF6, and then it can also pick up secondary gases, ammonia, ethylene, and then these come in, you can get these lenses in a 25 degree or a 6 degree. And then similar on the low range side, again, the spectral range is 7 to 8.5 microns. That's what it's tuned to. And at these microns, at these wavelengths, the primary gas that we're going to be able to pick up is that methane, with secondary gases of sulfur dioxide, nitrous oxide, and a couple of refrigerants there, 134A and 152A. Again, available in 25 or 6 degree lenses. 6 degree lens, if you're shooting objects at a greater distance, you're going to want that narrow focus lens. Base model camera and one lens starts at, you know, just under $30,000. FLIR, we have a plethora of other gas finding cameras as well that are more around the $100,000 mark. They also do not do thermal imaging. So this camera being a hybrid and really packing in, you know, a lot of features, a lot of different gases, you know, at this price is, you know, really astonishing, and something that our users have asked us for a long, long time. So definitely happy to get this camera out on the market at an aggressive price point with everything that you can accomplish with it. All right, so let's switch gears a little bit, and we'll move on to our acoustic imaging camera. Again, a fairly new category for FLIR, getting into this ultrasonic world. So just starting off, you know, maybe many of you have seen this chart before. It's called the DIPS chart. Basically, what it goes through is the life cycle of equipment or motors, right, that we might have in our facilities. So, you know, you have an original design, you know, you get a new press machine or whatever you have, a new compressor, and that thing should be perfect, right? It should be brand new. It's coming out of the box. It's, you know, getting loaded into your facility. That thing should, you know, be perfect. Then you go to install it, right? You're going to use precision, you know, laser alignment. You know, you're going to fasten it, you know, bolt it to the ground if it's a big piece of equipment like a press machine or what have you. But still, you expect that piece of equipment to work 100% correctly. And you're going to live in that world for, you know, a certain amount of time. Then you get to this P, where that's the point at which failure can begin to be detected. One of the first things, and this isn't like a FLIR chart, you know, this is a, you know, preventative maintenance, you know, type of, you know, facilities maintenance chart. But one of the first indicators that your equipment might be beginning to degrade is ultrasonic activity, you know, ultrasonic spikes. So that's one of the first things, and that's the camera that we're going to talk about today. You go on, then you can have vibration issues. You can have oil issues. You know, thermography, which, you know, again, FLIR is the worldwide leader, actually comes after some of these things. So you might have vibration problems before that equipment starts to heat up. So FLIR, we have an acoustic imaging camera. We have vibration tools as well. And then, as you know, us most commonly we have thermal imaging cameras. So basically, I kind of think about this as, you know, buying a new car. You buy that new car, it's only got, you know, 15 miles on the odometer from a couple test drives. You're like, okay, this thing's brand new. This is awesome. You're driving it around. You bring it in to get your oil change, right? You bring it in to get your tires rotated, all of that. You're going to do all of that preventative maintenance, right? You're not just going to run your oil dry. But maybe you get to, you know, 75,000 miles, 100,000 miles, now your brakes aren't working so good. Or, you know, you get up to 150,000 miles and you're driving down the highway and your car starts to vibrate, right? Whenever I get to 75 miles an hour on the highway, my car starts to rattle or makes different noises, right? So basically, you know, your equipment is going to have a lifespan. And what you want to do, the goal is to stretch that out with, you know, preventative, predictive maintenance and repair as often as you can to make sure that you're catching all of those things and your equipment does not degrade to the point of failure. So what is ultrasound? Let's describe some of the key characteristics. Ultrasound, it involves using high frequency sound waves, which are beyond the range of human hearing that are produced by equipment. The sound waves themselves are highly directional in nature, and so they tend to be produced by discrete localized sources. Ultrasonic waves, they also tend to be indicative of equipment degradation, like we talked about. So when we find them, we can use them as early warning signals of future equipment failure. And then lastly, ultrasonic inspection tools are a valuable part of a comprehensive asset management solution, which is important for helping companies save money, increase product quality and worker safety while reducing unplanned equipment outages. Right, one of the biggest cost savers cost to manufacturing sometimes can be unplanned, you know, downtime. Right, if you're supposed to make 1,000 widgets in a week and your machines are down for 3 days, I mean, you're only going to make, you know, 400 widgets. You know, you can't have that. You can't have that unexpected downtime. So we want to catch that as early as we can. So again, what is ultrasound? A pressurized leak that will cause turbulence, which can be located using ultrasound. When air leaks into the air, finding it using any other method than ultrasound can be difficult. With an advanced ultrasonic system, it can be easy. So again, you know, humans, we hear at, again, a certain range in this sound, in this sound bar. Dog whistles, right? Dogs hear at different ranges. So you could have a dog whistle, you blow that thing into the middle of a park and your dog might hear it, but no other human, yourself, they're not going to be able to hear that because their ears are tuned to a different, you know, different hertz on the wavelength. So our SI-124 or ultrasound, again, is we can't hear it. It's very quiet. It's more just almost like vibration, and our camera filters out all the loud noises that a manufacturing plant might be making, and just looks for these discrete small turbulences to show you where that leak might be. So how do we do this? So we have multiple microphones on our camera, 124 microphones on our camera, and they're casting out a net of you know, sound. So they're collecting sound, and it actually triangulates the sound. So we got many microphones coming, and that leak is hitting the various different microphones. And so depending on the angle at which that's coming into the camera, then we can locate exactly where that leak is coming from. So again, we combine that array of microphones with the camera to pinpoint it. You know, in imaging technologies typically provide a 90% reduction in inspection time. So again, using this camera, 90% reduction or 10 times faster, you're gonna be able to just take this camera, walk around your plant, and find any of these leaks. and you're gonna be able to do it 10 times faster than any other method. So why so many microphones? Our unit is called the SI-124, 124 meaning 124 microphones. So the more microphones improves the ability of the camera to precisely locate that leak. It's similar to, you know, pixels on a thermal imaging camera or pixels on a you know, flat screen TV. The more pixels that you have, the more definition that you're gonna get, right? There used to be 480, then 960, then 1080. You know, now we got 4K and 5K, you know, DPI TVs out there, right? And what does that mean? The more that you have, the clearer that image is going to be for you to watch and enjoy. So same thing here. We have best-in-class microphones, 124 microphones, which is best in class, almost 2 times our nearest competitor. And then what are the different applications where you might use an SI-124? So one is electrical partial discharge, compressed air systems, and then vacuum leak detection as well. There's some other ones here, but those are going to be, you know, really the big 2 or the big 3. And having all of that in one camera is also, you know, best in class. Being able to accomplish all of this makes it a very versatile camera. So first, let's talk about air leaks, right? And again, I love this image. You know, you got a leak here. You have compressed air running through this line. And if you have a bad seal or a bad connection, a bad elbow, you know, it's just leaking air. You know, that's really just leaking money. And there's been studies done by the Department of Energy that, you know, 30% of a manufacturing facility's electricity is consumed for compressed air. So not to power up the lights, not to turn on, you know, the computers, not to heat up or, you know, cool down the facility. 30% of that is just to run compressed air. That's a huge, huge number. And then on average of that 30%, a third of that compressed air is wasted due to leaks or misuse, pressure drops, and overpressurization. So, you know, a third of that 30%. So 10% of all of the energy, all of your utility bill that you pay for is being wasted, right, due to these leaks and misuse. And then if you kind of extrapolate this on a typical manufacturing facility, running a 200 horsepower compressor, you know, 600 to 800 hours a year, 11 cents a kilowatt, that means they're leaking $38,000 worth of air. That is doing no good. It's providing no value to the company. It's a negative $38,000 on your profit, on your bottom line. And then here are some images. So you get this black and white image, visual image, and then you get this, it looks like a rainbow circle, right? So again, this helps you pinpoint exactly where that leak is going to be. So all you have to do is, if this is your facility and you know this is where your compressed air is running, you just walk at a normal pace. You don't have to go painstakingly slow. You just kind of point and shoot this thing. You can cruise through your facility, and if there's any leak, you're going to get this. You're going to get this icon, you know, or this sensor, this rainbow pop up. And then you can stop. You can pause. You can take a picture. And then you can save that image and then continue to go on. You can take notes and say, this is on the northwest corner of the building, you know, or this is coming from compressor A or compressor B, you know, this line. You can take all those notes, and then you can also build a report at the end, which we'll talk about. Again, here's just another compressed air leak. Again, a bad connection here. You know, the other thing that, you know, maybe goes without saying, but we, you know, is valuable to bring attention to. If you have somebody that's expecting, you know, 200 PSI at the end of this line, you know, they're making a certain gizmo, they're making a certain gadget, and they have a pneumatic tool. And to make that item, to make that product, you need 200 PSI, and you're only getting 180 psi because you have leaks, or 170 psi because you have leaks. Now the quality of that item that you're trying to produce, your product, could be tampered with, right? Or there, instead of it taking 5 seconds to bolt that in or to screw that in, now it takes them 20 seconds because I got to use a little more elbow grease, right? So the quality of your work in the goods that you're actually producing using that airflow could also degrade. Partial discharge. So very cool. Theme of today is, we're making these cameras that are very versatile. They can do multiple different applications. So same camera, you just flip it on to the different setting. Now you're looking for partial discharge in high voltage utility applications. So, and it can pick up 3 different types of partial discharge: corona, tracking, and then both of these, can result in arcing, which is not a good thing. I'm sure people have seen videos of, bad arc flashes gone wrong. But, so imagine you're in a substation and you're looking for partial discharge in an insulator that's made of porcelain. If they get water inside or start to degrade, what could possibly happen? That could explode, right? Those insulators could explode. And if there's porcelain, those shreds go flying out, becomes very dangerous for both the people and all the equipment in that area. So how does this process work? First, we combine, advanced signal processing with AI to automatically detect and recognize what type of PD it is. So first, the partial discharge is identified by the SI-124. You point it at your equipment, at your targets, and you get your rainbow target there and says, hey, you got partial discharge here. You take an image. That image is stored on the camera and bounced into the cloud. Once you're connected to the internet, that image, and on our software that is free to use, that image is processed, right? So we have this artificial intelligence, and that image goes under processing to really understand and identify what it is. You'll have one of 3 things: discharge to air, discharge to the component, or discharge internally. If you have discharge internally, this is the one that indicates the biggest problem. Discharge to air, there is going to be a certain amount of discharge, and not necessarily means that anything is wrong, but maybe just something to note. After that, a determination is made based on the data that is given to you, if you have an actionable item or not, right? If this needs to be looked at. And the other nice thing about this is because you're catching it early, you can actually make that planned repair. If you do have to shut this down, you can actually plan that. It doesn't turn into emergency mode. You can say, hey, we need to have somebody look at this. Let's have them look at it, tomorrow morning at 6 a.m. or, tomorrow evening at 4 o'clock, right? You can plan that, and you can plan for those outages. You can plan for that downtime as to not disrupt everything else. So here is an image of a faulty insulator. So as you're walking by, through your substation, you might want to take images of anything that you see, on this insulator when we're getting this rainbow on here, indicating, partial discharge. So you stop and you take the image, you save it to the cloud, like we said, and then you also want to do just good practice. You also want to perform a visual inspection. Maybe you have binoculars on you if it's far away, but you want to make sure that the insulator is clean of any potential dirt, debris, bird droppings that could cause discharge on the surface of the device, right? Because those are going to send off, different discharges, different vibrations off that device if it is dirty. But if it is clean, then you might really have an issue here, and you would want to schedule that downtime. Here we see that the camera has done this analysis, and it is actually a discharge on or inside the component, which those are the ones that we want to focus on. and make sure that these get repaired. Then here again, another surface discharge on the insulator. Here you can actually see a little bit of vibration, and you can also set these cameras to see 3 different hotspots at once. But here we have, again, discharge on the surface or inside the component. And again, the other nice thing, and you can kind of see it from this image, these cameras, they have a range of 100 meters, so over 300 feet. So you can do all of your initial inspections, from the ground. You don't need to get the cherry picker out. You don't need to get in your bucket. You don't need to climb the utility poles to do these inspections. You can do them more safely. You can do them faster and more efficient by doing these inspections, right from the ground. Again, over 300 feet, this camera can see and give you a nice, clear image like we see here. This image right here is, now you can see that we have this discharge between components, this green indication. So this one is telling us, not necessarily a big hazard, just a little bit of discharge between the 2 components kind of bouncing off of each other, but not as much to take concern of, but still a nice image to take here. And it lets you know that, hey, this is okay. This is to be expected. So then really quick, just some features of the SI-124, features and benefits of the SI-124, then we'll get into any questions. Feel free to type in questions here as we start to wrap this up. But again, this SI-124 can do both air leaks, compressed air leaks, and partial discharge. It's super lightweight and portable, just over 2 pounds, and it can be operated with one hand. So it's just like any of our thermal imaging cameras, easy to use, just one hand. The operating range, again, up to 328 feet, that 100 meters, and as close as, about 1.5 feet. It has both a built-in and external battery, allowing up to 8 hours of operating time. So you can get a full day's work done with this on one charge. Excuse me. It also has Wi-Fi. So, if you have, a tablet or your phone and you want to process those images right away, you can actually upload those to the cloud and get that software, and you can look at those images when you're in the field. You don't have to go back to your desk to get all, to actually analyze all those images. And then it's got a 5-inch display, so nice big display for you to see. Operating temperature of 14 to 122 degrees Fahrenheit. And again, that's important because, some of these manufacturing plants, they can get hot, especially if you're in the southern part of the country. We're all coming up on summer right now, right? A lot of these facilities can run hot. This thing will work well over 100 degrees Fahrenheit. And then price, MSRP right at $20,000. But again, you find a couple leaks, and the ROI on this camera, is crazy. You can make that back in months, if not a year. So with that, I will turn it over to Keith, who's been managing the chat, to see if we had any questions come through.
Just so if anybody has any questions, they're free to type them in.
Perfect. And I'll give a plug to Photronic as well, Keith and his team. They have products in stock. They have training available. They have experts on their calls. So definitely reach out to them for any questions. If you're not typing in now, but you have one later on, definitely reach out to Photronic. They're definitely one of our better partners.
Haven't seen anything come up yet. Could all be like me and type with one finger, so we'll give it a little bit more time.
No questions, huh, Keith?
Nothing. I don't see anything, Russ. You did just a great job.
Yeah, it's either I did a really good job and there's no questions, or you know, we lost everybody. It was super boring and people just dropped out.
Well, I'd like to thank everyone for joining us. And again, if you have any questions, you're free to call us. I guess we'll be signing off, Russ.
All right, sounds good. I appreciate it, Keith, and Photronic team for having us today. And yeah, let me know any questions that come up later on.
All right. Have a good day.
Thanks. You too.